Okay, so yesterday we finished the installation and I have explained what all you need to learn before attempting this particular track of WebGIS. And we'll start with the concepts of WebGIS today, where we'll cover about what is WebGIS, why we actually use it, and of the architecture, what we are gonna use, and how you can set up your own, and how what are the other technologies that you need if somebody wants to host their own web applications. So first of all, what is WebGIS? So anybody wants to attempt? What do you know about what WebGIS is first?
I guess when we are doing any work related to GIS,
Yes.
those data is in our local system, but the same data when we are put in our internet and that those data can be accessed to any user. Those whatever we are preparing for that thing that is for the web change.
Yeah, so it's absolutely correct. So whatever analysis that we have done in our previous exercises and whatever data insights you have generated from desktop-based GIS or Python for that matter, and if you want to share it with somebody, what is the easiest way to share it is to create an application and just host it. But this is not as easy as it sounds, that just create an application and host it, because when you want to if you want to create your basic simple app, then there are a lot of available tools like Google Earth Engine also helps you create an automatic app of your analysis. But when it comes to interaction, when it comes to creating your own drop downs and adding more than 2 to 3 analysis in a single application, then there comes a challenge where we are integrating. Let's suppose you have 10 data layers, and how you host, how you integrate between your databases, how you connect them, there comes the challenge. So there are a few concepts like server client architecture, client side libraries, and standardized services comes into the picture. So what is server client architecture? It is basically, I have previously also mentioned, whenever we link our data to a website, there will be two things. One will be a server side and one will be a client side. Client can be a user, which can be you, me, or anybody else, whoever is using or seeing your application. And server can be the one where you have put your database, where you have hosted your application, where have you put your codes and everything that is needed for the interaction that client wants to do. So that is called server client architecture simply. And then there are client side libraries. So why I'm saying it as a client side libraries, because these are the libraries which will help you to create a front end, and the front end will always be used by the client, which will be a user. That's why we call it as a client side libraries. So there are many libraries like Leaflet, Mapbox, JS, and ArcGIS APIs as well. But since we're only focusing on the open source content, so in the PPTs and in all my discussion, we will only be discussing Leaflet and Mapbox JS, because these are free open source JS libraries, and the main purpose of these libraries is to help you create a GIS focused web application. As we have studied in Python as well, that there are packages available within the Python that they have made specifically for GIS tasks, which you can directly install and call and use it for your specific tasks. And let's suppose you want to create a buffer, so there was a tool for buffer. Similarly, they have created a JavaScript libraries called Leaflet and Mapbox.jl, where they have created multiple functionalities which people use regularly for creating a web-based GIS application. Let's suppose you want to add a map. So there can be 100 line of code to add a simple base map to your application. But what Leaflet has done, they have already written those code to add a base map and everything. They have curated. You just need to call that URL and just use a simple function, and then you will be able to integrate their functionalities into your web application. So that was the simple meaning of client-side libraries. So you can just imagine, think like in Python, we used to call it as a packages, whereas in a JavaScript, whenever we are linking any third-party APIs, we will be calling it as a library. So Leaflet and Mapbox GLJS is not a very small libraries. There are very big libraries which serves lot of purpose, and we'll be using these libraries only to create a full-fledged web application. Next task is there is something called OGC standards. So when we say I'm saying OGC standards, so there are certain guidelines which are set by the OGC for serving data or like your static data into an interactive web-based platform, because you cannot simply just host your data and just use it in the web application, because you already know that we are dealing with the GIS data. It's a very heavy data which is not feasible to like fetch directly. So in order to do that, there are multiple type of services that are present, like WMS, WFS, and WMTS. WMS is simply web map services, FS is feature services, and MTS is a map tile services. Each have its own benefits and pros and cons. If I talk about WMS, so you can say that whenever a WMS layer is called in the web application, you have converted your data into an image format and you are just fetching the whole data. You haven't converted those into the tiles, and while you are calling the data, it is just rendering on the client side, rendering while you are calling the data in your front end. Whereas feature services is simply you have just put your data as it is. If you had a point layer, polygon, or a line layer, you just put your data as it is and served it as a feature service, and consuming, you are now consuming it in your web application. For consuming the raster data, we have something called WMTS. So means we are converting our whole raster data into smaller tiles, and then we are consuming that data into our web application. We'll see a demo of each of them one by one when we'll do the hands-on. So these are the few standard that OGC provides how you can serve your data into a web application. When it comes to WebGIS architecture, um, there were two things I told. One is the client side, another is the server side, and now comes the third layer is the database layer, obviously. So in the client, what will be there? Client is the one that is facing like whatever you can see on the application. So it will contain your HTML, GeoJS, your libraries, user interaction, everything that is related to these categories we'll always be calling it as it is happening on the client side, because I'll be using this term more often that we are doing client side query or the server side query. So you should be able to differentiate between the two. Whenever something you are seeing on the map, which is you are using for the presentation purposes, for the visualization purpose, that means simply means that we are talking about client. And HTML is used for creating the wireframe of your application. So it's a client facing thing. JS libraries, we will be using it for adding the interaction to your application. So that means it is a client side libraries only. User interaction, obviously panning, zooming, querying, clicking on the, creating the drop downs, adding the table, clicking on the table and highlighting on the map. All those things are coming on the client tier only. So once the user is sending the request from the client tier, means from your front end, we'll be sending the request that what you need to display on the map. That request is gone to the server tier, and then when it goes to the server tier is where your application is present. So in our case, we will be using GeoServer. GeoServer will be using to create compatible services. It is mentioned here, it is a map publishing engine. It will help you to create your data in such a way which you can consume in your client, which you can display. So once the client is requesting some layer or some data, so it will be fetched from the services like the WMS services, WFMS services, in whatever way we have hosted our data or we have consumed or created in our GeoServer, it will be displayed in your client. Similarly, the styling part, the visualization, the symbology, or everything will be set in the Geo server only using the SLD's styling and everything. So whatever style you have set in the Geo server will only be displayed on the client tier. It will not be like that you have set the symbology from the QGIS and that will be displayed on the web map. It doesn't work like that. We need to specifically set the symbology in the Geo server. Or let's suppose GeoServer and ArcGIS server are like the same thing, which are used to create your data into a feature services or some kind of a services so that you can consume in the front end. So there only, let's suppose we are talking about ArcGIS. So in ArcGIS server only, also we set the symbology and everything there while creating the web map. Whereas in GeoServer as well, using SLDS styling, we'll be seeing how we can set the styling symbology and publish the layer there and then consume it in your client tier. Then, while you're creating the web map, if I compare it with ArcGIS, you also know that why in the ArcGIS as well, in the backend, the data is serving from the Postgres SQL only. So the data is fetched from somewhere. Then GeoServer is like a bridge between the two, and there you have fetched the data from your server, and you're creating a kind of a web map or a service or a WMTS service or FS service, and then you are styling it there and serving it. So this is a three-tier thing which will be happen in every case. Yeah, you will be fetching the data from your database, which will be hosted in maybe PostgreSQL. Mostly it will always be in PostgreSQL only because that is one of the commonly used database for GIS data. And we discussed a lot about PostGIS extension and storage in all different formats. So you'll be storing the data, serving it into the Geo server, creating services, styling it, and then after styling, we'll be displaying it in our front end in the client tier. So this is the three structure which we'll be following. The same thing that I just explained, that we'll be dividing into client and server. A little more explanation about the client. Yeah, you can think of QGIS also like a client, though it is not related to the WebGIS, but I have just put this image for the context because QGIS is also a kind of a platform where map is present, where you are fetching the data. So we have seen in the previous sessions, like we used to fetch the data from PostGIS and display it in the QGIS. It was also like a client and server interaction, that we are fetching data from somewhere and displaying on the basis of the request uh, from the client side. So similarly, we have OpenLayers and Leaflet, and there are other libraries as well, which one use for creating a web application and fetching data from the server.
What is the difference between OpenLayer and Leaflet? And
OpenLayer and Leaflet these are just different ways to display the data. There are two different libraries which will help you to like add on the base maps, add on the different type of features. There is no such kind of
I know which one I have to choose. Like there is any complexity in my work, so I have to choose any of them.
That is depending doesn't not that complexities. Leaflet also have everything that you need for creating a web application. It's just depend upon how comfortable you are with which libraries. For example,
Okay.
I always prefer Leaflet when I go to open source. So it's like that because Leaflet has a lot of documentation. OpenLayers, I'm not saying OpenLayer doesn't have any kind of documentation, but it's just Leaflet is more used by people. So I get a lot more resources for Leaflet just by a single search. So that's why I prefer Leaflet. It's not depending
Okay.
on the complexities of the work. You will get things in both of the things, more or less.
And the request is whenever you are talking about the API and all, can you please demonstrate about the ArcGIS API and all, how we can use that? Just like
ArcGIS API will not be able to demonstrate since it is
no,
Huh. It is now the demo. I'll not be able to do it because we don't have license for the database.
mm,
How will I connect and all those things? That's why we'll not be touching ArcGIS APIs for now.
okay.
I'll be sharing. I can share the resources and everything. How you can create, how you can see to use the ArcGIS APIs and everything. But for the
Yeah, I just
demo,
want to know the But the rest is that's it. Because I know that there is a license thing, so
Mhm.
we can't do that. But I just want to know the methodology. Like, is it totally same wise for leaflet, open layer, whatever we are using here? Is that same or with
See,
something different is
see,
there?
it will not be same because the writing, the structure, how you write the code will be different. Uh,
Mm-hmm.
uh, for example, if you choose leaflet, they always do like L dot tile layer. For open layers, it's different. When you go to ArcGIS APIs, if you go to ArcGIS 4x version, they have two versions. 3x is more expired, like they are not giving maintenance for that. But currently, they're using ArcGIS API 4x, where you need to write it in a different way because that is mostly written in a React version. You cannot use a basic JavaScript for writing a 4x API. For using ArcGIS 4x API, you have to write it in React, which is a advanced version of JavaScript APIs. Whereas for integrating leaflet and open layers, you can use basic JS. So those the syntax, the how you write the code, everything will be different. So it's not like everything is same. Leaflet is different JS library. OpenLayer is different JS library. ArcGIS is a different JS libraries. The structure, how you write the code, is totally different for all three. So that is why yesterday also I mentioned that for writing the code, how you write the code, how you have to write the JSON code, you need to learn the JavaScript first, and then you can move on if you want to create an extensive application. Uh, in sessions, we will be focusing only on helping you how you can integrate and what are the different components that you need to create a web application. We will not be going deep into the JavaScript because JavaScript is a complete language itself. If you are aware, so that takes a complete total session, like it will take you at least 3 to 4 months, to be very practical and honest. It will take you if you are learning by yourself and by, like, if you're learning every functions. But given the tools, a lot of tools and functionalities are provided and present in today's time, that if you use them correctly, you will be able to do all those things. But for using those tools as well, you need to have your basics clear. Otherwise, you will be just copy pasting the codes from somewhere. Okay.
Okay.
The syntax will be different. I'll show you the syntax also when we'll do the hands-on. Just a minute. For example, we'll discuss this hands-on also. See, this is the structure will be same. Like there will be HTML page, there will be JS page, there will be CSS page. But how you write it? Let's suppose I wanted to integrate leaflet library. So I use these CSS, which was for leaflet. This JS, which I use for integrating the JS code in my application, and for integrating the tile layers, for having the base map and everything, there is a different syntax like L dot map if you want to add a base map, L dot tile layer if you want to add a different tile layer. Here is a base map that we are adding, that what kind of a base map you want to add it as a in your application. So this is a syntax. Whereas if you go to the ArcGIS one, just a minute. See, if you can see here that for adding the for integrating the basic ArcGIS API is the same. Like you, for adding the CSS, you added the CSS link for ArcGIS, you added the JS link for the ArcGIS. So that is the same. But again, for inside how you are integrating that API, that syntax is completely different, because in a leaflet there is no concept of web map. But in ArcGIS, there is a concept of web map, feature services, different other group layer, map image layer. So there are different syntaxes or different functions that are available with ArcGIS JavaScript libraries. So how you're using that libraries will be different. For adding the view means for adding the base map, we use in ArcGIS we use map views. For while you are adding the map view in this map, either you put the web map. In the web map, either you can define the ID or you can define the URL of the web map. Let's suppose you don't want to add the web map, you want to add the feature services. So we add this, add a feature layer here, and then we consume the feature layer in the map views while adding or while using the JavaScript API. So the coding structure will be different. Okay.
Okay.
And you need to pick one. Matlab, you cannot jump around the libraries while doing a single project. Choose one library, and then create a project on that. Uh, you cannot integrate. It's not advisable that you integrate two and three. Though JavaScript ArcGIS Map SDK also provides some functionality along with Leaflet. They have that function as well. You can go into the reference and look for that, but choose one and then stick to that and then create as per your requirement. Okay.
Okay.
But if somebody is very new and don't know anything, then it's advisable to start with Leaflet and master the Leaflet and basic. In today's sheet as well, I have shared the reference for the JavaScript. So first try to understand how to write basic JavaScript code. Then go with Leaflet. Leaflet is very easy and very easy to learn and integrate. And just by a single search, let's suppose you want to add a zoom, you will type on the Google that I want to add a zoom. You will get a 3 line of code. You can copy and paste and read. By that you can learn. Then once you mastered Leaflet and basic JS, then come to ArcGIS Map SDK, because ArcGIS Map SDK syntax is based upon the how you write the React code. So React is a like a little advanced version of JavaScript. So go by this. Or if you're confident, then you can directly jump to any of the libraries which you feel. Okay. So back to the client and server integration. So client, I'd already told you that there are many libraries present. You can choose as per your requirement or as per your experience, that whatever you want to choose. And but open source, if you're going with open source, one should choose Leaflet only. And then when we come to the server side, so in the server side, again, I have only mentioned the open source only. The geo servers and the map server are the open source, where you can host your, like, link your data and convert your data into services which are consumable in your web application. So there will be three things. One will be a web server, another will be a GIS server, third will be a GIS database. So same thing, in the GIS database, we will be having the PostGIS. In the GIS server, we'll be having GeoServer. If we go to the proprietary, in the GIS server, you can have our GIS server as well. Whereas in the web server is used for hosting the application. Let's suppose Git can also be one of the web server. Let's suppose you are hosting a very simple basic application where there's no much data integration or anything. You can have your application hosted in the Git, and then you can host it any of the cloud and then integrate and create a whole application like that. A, a little more detailed description of, it's the same thing, like you had the data, you'll create a WebGIS backend. In the backend, you have processed everything. You hosted your processed data into Postgres SQL. Till here, we have done everything. Like we processed the data, we created the data, created an analysis, and then hosted our data into Postgres SQL. Now, after the hosting the data into PostgreSQL, now we have to choose what kind of a server that we need, where we'll be linking our data so that we can create the services and then ultimately consume it in the WebGIS front. So there can be multiple server, Apache server as well, where you can host your Java or anything if you have PHP application. Let's not go into the PHP for now. Let's suppose we have only Geo server where we are linking our data and hosting everything and creating it into a web service and then consuming it into the web application.
Ma'am,
Yes.
just one query. Like you mentioned, like Apache server and Geo server, both the thing. So, like, is it like when we are doing some open source application
Mm.
or develop some open source WebGS thing? So we
Mm.
can do, I mean, everything, whatever we will do, we can do using GeoServer only. I mean, when we need this Apache PHP server, is there any particular thing like
No. No.
when we are doing Apache for particular that analysis, we'll need that PHP or everything we can do using GeoServer only?
No, everything you can do using GeoServer only, but GeoServer is only used for linking the data. Let's suppose you have your analysis and you created the data layers only. For that purpose, only for creating the feature services. For that purpose, only you have a GeoServer. What about your application? Where you will put your HTML file? Where will you will put your JS file? Let's suppose you created some backend APIs where you'll put those APIs. So for that, we need different servers as well. So there will not be a single server. Geo server is only a GIS server. In this, I mentioned there will be three things. Web server. So web server can be a Apache server or it can be any other kind of a server. Whereas GIS server, in the GIS server, we can have Geo server or ArcGIS server, which will help you to just convert your data into consumable services. But what about where you'll host your DB? Let's suppose PostGIS. So in the previous session, we had installed the PostGIS in our local system. But when you will be linking it to a running application, a production level of application, you are hosting everything, you need to host your PostGIS as well into that server. So there comes the Apache server or any other different kind of server which we will be using for doing that. Just give me a minute. Let's suppose you must have heard about the Google Cloud or the AWS servers or the Oracle Cloud. So these are the bigger level of virtual machines or the servers they have. Inside that bigger server, we install the small server which are specific to our use case. So let's suppose you have a bigger AWS server. In that, we installed the Geo server because GeoServer will only do one thing. It will only convert your data into consumable services. Where will you keep your DB? Where will you install your PostGIS? So for installing the PostGIS as well, we need a bigger server. So in the AWS, we install GeoServer. In that, we also installed the PostgreSQL. And for hosting your web application, you can use Apache, Tomcat, all these kinds of things and different kind of servers we can install. So there will be three things inside that bigger cloud version, which will serve different purpose, and then we'll link all these three together. Uh, the thing that I am just telling you right now, and these are used when we are creating a production level of application. Okay, I hope I'm a little bit clear what I just mentioned.
Yes. So, like, basically, it is like whenever we are doing our data, I mean, when we post, I mean, when we are store our database into cloud, that time we need this Apache server, right?
Yeah, correct. That time we need these Apache server and everything. Though GeoServer can work in our local system also, like because there is something called Jetty. If somebody have noticed yesterday when we were like running the startup, at that time in the command prompt, you must be saying that Jetty somewhere. So Jetty is kind of a small server itself, which will help you to run the GeoServer. It can run on your local also, but it will not work when you are hosting your application somewhere so that other people can watch it or other people can use it. At that time, we need to host GeoServer our PostGIS database, our application, all three into some kind of a bigger cloud server as well. So there are concepts like load balancing, and like people host all these three things in different servers so that it doesn't load any single server for just for managing the load and the people frequency, if somebody is using these servers frequently or your web application frequently. So that is the kind of flow that we need to follow. So if you I just sum up what we discussed. So basically we prepare data. You can prepare data either in QGIS, Python, or whatever suits you. Then you load your data into the PostGIS, install PostgreSQL, and now imagine that PostgreSQL is also in some kind of a cloud software, either in AWS, either in Google Cloud, either in Oracle. There can be many. I'm just mentioning these three because they are famous and widely used. Then you published your data into some kind of a GIS server. Why we use GIS server? Because there are certain OGC guidelines by which we need to follow to host our GIS data, because normal databases or normal servers cannot handle the GIS server capabilities. For example, ArcGIS server is built to create the feature service and everything, whereas GeoServer is built to handle or feature services, WMS, WMTS, tile layers, WFS, feature services. These capabilities are not present in Apache server, or these capabilities are not present in any other kind of a server. So for those, we specifically need some server which have GIS compatibility. So GeoServer is open source, ArcGIS is one alternative which is proprietary. So we create all these things. Now we build the web application. Let's suppose you have created in your local. For now, just assume that you have created this application called Leaflet, where you have all your index, HTML, JS, CSS file, and you have created a web application on your local. But in order to serve it into some kind of a web application, like a so that other people can use it, you need to host now. So where you will host? So now you will deploy your GeoServer, your front-end application, and your PostGIS, all three things into some kind of a cloud virtual machine or any of the server which is compatible to handle all three. You for a basic small practice task, you can do in a single virtual machine, or for scalable purpose, there is a complete different study about system architecture, which people study and understand how to keep different application or different databases in a separate server so that they can have a fast running application. So this is the whole architecture, how you handle and deploy all these applications. Okay, so we discussed a lot about why we need WebGIS. So real world impacts, logistics and delivery. There are a few examples like Swiggy and Zomato. They are all based upon GIS applications. Like they have map enabled in it. Google Maps, they also have global routing, real-time traffic, mobility, or you have many more examples. Let's suppose we are talking about the flood analysis. So let's suppose we are creating any real-time monitoring app for flood, for active fire, for any kind of like for landslide monitoring, disaster management, any kind of thing which are usable and for getting the real-time updates, for collaboration with other people. Let's suppose you want to send it to somebody, cloud integration. Like let's suppose you have created your database, but let's suppose whatever data that you're seeing in the Google Maps, that is not just created by the Google Maps. There can be 100 companies which have helped in creating that data which we all are seeing in the Google Maps. So how you can integrate those data into a cloud data? So there must be 10 companies that are publishing that data into a single cloud, and then they are just merging it together, and then we are able to see into that final application, which is an application. So all these capabilities, we all know that WebGIS is very powerful, and we need to like learn, because just creating the analysis is not enough. Okay, so anybody wants to tell what is the difference between desktop GIS and web GIS? I think this is a very easy thing. We have already discussed this.
And the main difference is on the internet side, I guess, because when
Hmm.
we are using the desktop GIS things,
Hmm.
we cannot share that particular file or particular application, whatever it will be there. Cannot
Hmm.
share it to the all the people or all the user. We have to share one by one. But in the web GIS, the same thing we can share to the multiple person. First thing is that. Second is like in the desktop GIS, we are creating some small parts of the web GIS thing. So web GIS is a big kind of, we can say that this is a building, but the
Hmm.
desktop GIS is a small rooms.
Hmm. Okay. Yes, correct. So he was right. So in a single line, if I sum up the whole difference between desktop GIS and web GIS is simple. That desktop GIS will help you to create things. Let's suppose you have a raw data and then you are able to create the analysis and bring out the output and everything. And WebGIS will be, you will be able to, it will help you to share, to visualize, to demonstrate those raw data into some meaningful impact, which even a layman, a person who doesn't have any understanding about GIS, so without even mentioning the term like GIS, you are able to showcase whatever you want to tell. So, uh, when I look at WebGIS, I always think that in my web application, in my dashboard, there should be a story which I am able to tell without mentioning any of the technical detail about that particular topic. So somebody have asked me about like how to display the results in the capstone project or in the portfolio. So my recommendation, or I always follow that there should be a storytelling, that there should not be too much technical details, because if you are able to tell your story, the other person will already understand that you are well versed with technical things as well, that if they need, they will ask you those technical things. Next, now we'll move to the leaflet basics. Okay, just one thing is missed. Okay, we'll do this later. I'll show you how a layer and everything once we are doing that. Huh. Now, important thing is tiles and web caching. So there are three types of data, spatial data: raster, vector, and tiles. So raster and vector, you already are aware what it is. New type of data that comes into a picture is tile. So whenever we are dealing with WebGIS, tile is mostly used by everybody. So it is kind of a pre-rendered chunks, and it is used for fast web display. So once we were creating the Folium web maps as well in the Python. So you must have seen that a lot of times I have converted the raster data or a GeoJSON data into a PNG, into a image format, so that now it is faster to visualize and it is easy to load on your web application. So simply when you are creating a web application, the main task is to create a faster browsing application. So one way is to convert your data into a tiles and then display it. So pre-rendered chunks means you have already converted your data into tiles. You have stored into the Geo server, and then you are serving into the web application as a tile only. So how basically tile works? Simply, let's suppose you have a tile of a complete data for the whole world, and you have just distributed into a smaller chunks, as you can see in this image, that we have this whole thing for the whole world, and then we have distributed into a smaller tiles, and those tiles can be accessible on the basis of the zoom levels. So while we are creating a web application, we also set a center and the zoom. So there are two main properties of a web application. One is center and another is a zoom. And the scaling, how we set that scaling. So center means, so let's suppose you have any data, and on the first go, when you open that application, where do you want it to be displayed? So we define a latitude and a longitude. You can also define the extent as well. If you have, let's suppose you have a boundary layer, and on the basis of that layer you want to fetch the geometry and the focus on that geometry. Or you can define a center that it should in the map screen, it should center onto this lat long. Then zoom level, what zoom level will decide that at a first glance at which zoom level it should display. So zoom level will decide that how many tiles should be visible at that particular level. So it can range from 0 to like many levels are there. So let's suppose we have 10 zoom levels, so maybe it will be scaled at a country level or a state level. So like that we'll be seeing how you set the zoom level. So on the basis of that, as you set the zoom level, it divides it into different tiles. So in the previous, I was mentioning about the WMS and WMTS. So the main difference between the WMS is WMS will create this tile on the go while you are setting the zoom level, while you are zooming onto the map and everything. At that time only it will create the tile. Whereas while we are choosing the WMTS, like the tiles itself, so that means we have pre-rendered that tiles, pre-created, converted our data into a tiles, and then while just we are opening our web application, we are just fetching those tile itself while we added that zoom level. So which will be faster out of two? So obviously WMTS will be faster out of them because we have already pre-rendered the tiles and we are just fetching those tiles. Whereas in WMS, it is also a kind of a map service only. That means it will convert into tiles and display it to you, but it will convert while you are searching or while you are querying, while you are zooming in and zooming out into the web application. So a little between difference between the two, but more or less it's same. But only WMTS is used widely for a larger data. Let's suppose you are displaying the data for the country level, for the whole country, for the whole world. Maybe somebody is creating a wind diagram or a wind application. We are just showing everything. So for those kind of applications, they prefer tile services to show. And all these base maps that you see in any of the application, these base maps are all tile services. And that is why they are loaded too fast because they are already pre-rendered tiles which are present and they are just fetched like that. So the same thing is mentioned here. WMS is on demand. Server renders map image dynamically for every request. High CPU load. The same reason because it is rendering and creating while you are requesting. Whereas WMTS, it is cached, means server sends pre-generated static images as a tile. So it will obviously instantly load while you are just searching it. There will be a concept of web caching. So web caching is simply means the thing that we were mentioning about WMTS is that it will while we will be using this Geo server, I'll also show you how it's stored. It uses a concept of Geo web caching. Geo server use the concept of Geo web caching, means when you serve your layer as a WMTS, then it cache means it store in a cached format in your browser, and then it just gives you that image from the cache memory, and until unless you delete that cached memory it will be stored. So when I was mentioning about that you need to close your Geo server from the shutdown, not just by closing it from the browser. So that is what I meant, that yesterday we haven't loaded any data or served any of the application from the Geo server, so it was fine. But once we'll be going to the demo and serving the layers and everything from the Geo server, so while you are opening that layer into a browser, it will be creating a cached memory, and that cached memory will be saved in your folder in your C drive. That images will be saved because right now we are serving that Geo server from our local system. So it will be saved in our C drive. So if you don't stop it from the shutdown, you will be, even if you close your laptop, it will be creating that cached data while it is closed also. So it's important that you close it from the shutdown, otherwise that cached memory it will be keep on creating there. So that is the main thing that what I wanted to mention about the caching hierarchy. So simple tiles are stored at multiple points to minimize server request. So when you open any of the layer in the browser, it just store that cached PNG files into the Geo server and serve it from there every time you request it. The URL pattern we'll be seeing once we do the demo. And same thing that I mentioned, it uses a Geo Web Cache. I'll show you also in any of the application. Let's suppose you have this application. We'll be opening the developer tool. And if you go to the network option, if you just filter PNG from here, you can see as I am zooming and zooming out, it is sending the request now. If I just clear it from here, right now there are no requests. As I'm zooming in, now the tiles are coming. So it is basically, it has broken the whole map into multiple smaller tiles, and it is serving it as a .png format. So as you are zooming and zooming out, it is serving you from there. So that is how it basically work. And we'll also see in the Geo server also, I'll show you. We'll cover the leaflet also today. It is very small. We'll see how to set up and create a basic map. So Leaflet is again a very lightweight open source JavaScript library, which will help you to build interactive web maps, add on functionalities like zoom in, zoom out, everything. And it is very simple to integrate. It is very easy to learn and use. So what all key features are there? It will help you to add map layers, tile layers, markers, means point. You can add pop-ups. You can add on vector layers like point, line, GeoJSON, all the formats it supports. For raster, obviously you need to serve it as a tile layer. Then there are built-in functionality like the functions which are present with Leaflet. Few functions are like zoom, scale, layer switcher. Layer switcher simply mean like a layer list where you can switch off and switch on the layer, and you can on and off the layer. Attribution control for standard map navigation simply means like let's suppose you want to PAM in the whole map, pan, or create. If we have integrated a 3D data, we'll see for that how we can deal with all these navigation and everything. Then there are functionalities for clicks, mouse over. Let's suppose you are hovering over the map and you want to show the lat long of that particular area where your cursor is moving. So that is what it meant by mouse over. So there is a function how you can just enable that in the leaflet while you're creating a web map, and you can have that functionality. And heat maps for clustering, for draw and edit tool, there is a complete function which will help you to just add draw and edit tools by a plugin, and a geocoding service as well, and a heat maps and clustering. We'll see all these examples one by one. Basic setup of leaflet we'll do today. So we'll create a HTML file. We'll add few basic styling and a JavaScript logic. In that JavaScript logic, we'll simply add a base map for today, and we'll create a map. So for creating that, you can, I'll just show you, you can create a folder, simple folder. Let's suppose demo folder, you can name it anything. Inside that, a preferred structure for creating a web application is to have a HTML, CSS, and JS file as a separate files. But for now, we are doing everything together. So you can, you need to install Visual Studio Code if you don't have that. You can open that folder into the Visual Studio Code, and here we'll create a new file called index.html. You can name this file anything, but we are using index.html is the preferred name for creating index.html file. So .html with the extension for HTML, .css will be the extension for the CSS part, and .js will be the extension for our JS files. So while you have created this file here, and now we'll start adding the code into this. Now we'll come back to this. So a basic structure of the HTML code is to have HTML tag, head tag, body tag, like this. So HTML tag will be the main base tag for creating an HTML file like this. HTML open and close tag. Again, I mentioned learn how to write HTML, CSS, and JS. Inside the HTML tag, there will be two things, head tag and body tag. By the name itself, it suggests head means all the main thing will be in the heads, and body means how the main physical appearance of your web application will look like, will come inside the body tag. So in the head tag, if I am expanding, so there will be a title tag. This title tag will help you to add the title of your web application. So let's suppose here we are adding a title called My First Map. Then one of the important thing is now we need to link our leaflet library. If whatever library you are using, any kind of a third party API, if you're using, let's suppose there are multiple APIs which comes for integrating CSS and everything. There is something called Bootstrap, which you can integrate into your web application for having different UI and everything. But for Leaflet, there is a specific CSS they have provided. So you will be using this link to integrate the leaflet.css. The CSS will always go inside the head. We'll put this link in this type of syntax, link relation style sheet, and in href, we will put the URL. So like that, we have put the URL for the leaflet.css. Right now, we are using this inline in this style inside the HTML. If we had a different file for style.css, I would have just added a new link here and added a path to that particular style. I will show you that also. I don't have that right now. We'll see that later. Okay, no, I have just. So let's suppose this was an index.html file, and if you have a separate style file like this, in this style.css, if you go to this HTML, you can see that this is the MapLibre CSS that I added. In our case, we are adding leaflet.css. And if you have your custom CSS in your file, you have added some kind of a CSS and you want to integrate that also into your wireframe, then we will be using the same tag, link relation style sheet, and then in the href, instead of that third party URL, we'll be adding the path to our CSS which we want to integrate. Like this, we'll come back to. Okay. So we added our CSS. Now we are adding the style in this. So if you are adding the style in your HTML only, you need to use the style tag. So style tag, we have put a basic style in this. And then we'll come to the body part. In the body part, we'll set how the wireframing of our application will look like. So before we go into the script, in the body, we are putting that this is the div. Div is the kind of a thing, kind of a tag that we use to create containers. Let's suppose you want to add a box, add a text box like we add in PowerPoint. So for adding that box into your web application, we use a tag called div. In that we are defining a ID. Means obviously how will you associate that, which box you want to associate while we are doing the interaction using the JavaScript. That means JavaScript will help you to add things into your wireframe. So in which wireframe, in which number, in which sequence you want to add. So for that matter, we add a ID. So here we added a ID. ID is equals to, we given the ID called map, and we created an empty container for now, and we'll add the interaction later. So right now we just added a container, and then in this container we are giving the styling. So how we give this styling? So if you have the ID as map, so we use hashtag and give the name of the ID, and inside that we define. So right now we have defined what should be the height of this particular container, and margin, there should be no margins, and the height of this container should be 100 vertical height. So that's it is what we defined right now. And obviously whatever tag is open, you need to close that tag. So body we opened here and we closed that, and HTML also we closed here. So this is just the wireframing till now. There is no interaction till now. Now we'll add the interaction by using the JavaScript library. So for adding the JS, we will use a script tag. So firstly, I am just So firstly, I'm adding just a third-party JS file which I want to integrate, which is a Leaflet.js, because I want to use Leaflet for my web application. So I have used Leaflet.js. This is the URL, which this is a fixed URL that you need to use. There is no change in this. You added the script tag. In the SRC, we are passing the URL. Another thing, let's suppose you have a different JS file where you are adding your things. In a similar way, you can add by adding the path of that particular JS file. You can see here that in this, I have added my custom JS file where I have written the code for my JavaScript like this. And now I want to integrate this JS into my wireframing. So I used a script tag. In this RC, I gave the path to my file like this. So this is the path of my file. Or if you are using any third-party API, so you will just simply write that URL in the script tag. So this has integrated leaflet.js. Now we have to add, the first task was to just simply add the basic map into our application, and in that there should be a base map, and also it should center into some kind of a latitude and longitude, and there should be a certain zoom level. So these are the three things which will add. So obviously for adding any kind of a JS interaction, either you create a script file and tag it into your HTML, or you create a script tag inside the HTML and write your JS code inside that. So for now, we are creating the script tag like this: open the script tag and close the script tag. Inside that, we'll write all our interaction. So first thing is map initializing, means we are simply adding the map. So we have created an object called map. In this, I want to initialize the map. So L is the, you can say like we used to have pandas as PD. So similarly, there is nothing like leaflet as L, but directly if you are integrating leaflet.js, so we have to use L everywhere to integrate leaflet, and then only we'll be able to use the functions that are available with leaflet. So L.map, it will help you to initialize the map, and then inside that what you will give the ID that where you want to initialize that map. So now we have given the ID of a div container, which was the map inside this. So L.this map is the function which comes with the leaflet, whereas this map is the ID which we have defined for our container. Then set view. So for example, in ArcGIS SDK, I was showing you that there was something called map view, whereas here there's something called set view. So these are syntax difference, and there are functions difference will be there among different libraries. So set view, in the set view, we are defining two properties. One is the center, you can see, and another is the zoom level. In the center, you can pass any of the latitude and longitude where you want to center your map initially. And then here is the zoom level. You can set 1, 2, 3, 4 as per your requirement. We'll be seeing how it is changing. So the center and the zoom level. So this was it to initialize the map. Now on top of this, whatever will be adding will be, it's like we are adding on that particular map view that we created. So a view, so we create a container, a wireframe, then we added a view using dot set view from the leaflet. After adding a view, now we are adding our layers. So for now we are adding just the base map. I want to add just the base map. So this was the syntax to add the base map. So L dot tile layer. So there are multiple tile layers present. I have also shared here in this, I have shared the URLs. So if you will go to this first URL, there are a repository for different kind of base maps. So you can switch the base map from here and you will see the like a way to integrate those base map into your so variable like this. You can copy the URL from here, attribution and API key and everything, and then you can just use it in your web application. You can copy paste from here. And sometimes maybe some of them doesn't work, so you need to check the documentation also. But everybody take the URLs from this particular website only, and they keep on updating also. This is the official like URL from the leaflet only. So from here only I have took the URL. So simply like l.tile layer, and then I have put the URL that what kind of a base map I want to have. In the attribution, like attribution, we need to give like it's kind of defining the source from where we are sourcing, just to give the credit if we are using it for commercial purpose. Otherwise, we can skip also, but we need to give the attribution, so it's better that we give it. And then obviously add to map. Simply add to map. What is this map? This is the map object variable that we created. So everything now that we want to add into our map is simply like add to is the function that we'll be using to add the layers onto our map object, the view that we created. And then close the script tag, body HTML. Now we'll run this and see how it looks. You can go from go live also, and you can also just double click on index.html and you will see something like this. So by default, when I am seeing it is centered on Delhi because I have used the latitude and longitude of Delhi. Let's suppose if I'm changing the lat and long, not lat and long, if I'm changing the zoom level, let's suppose I have put 2. So you can see that 2 is the zoom level. If I am putting it as 0, so this is a complete world. So as you keep on increasing, it will start zooming in into the world. So let's suppose for now we'll keep 5. So maybe a whole India is looking like. So this is how you can just set your zoom levels as per your project requirement, as per your study area, and obviously give the latitude and longitude of your study area as well. Let's suppose take a different lat and long. Let's suppose somebody's study area is maybe Mumbai and you want to center it into this particular level. We'll give this center. Make sure that you are using the correct order. It should be like this only. It was correct. I put the correct. If I'm increasing the zoom from here, it is now zooming into this particular location. So this is how you can set the center and zoom level of your application. I have put 2 more URLs for the reference. If I just change it from here, This is, I think, in the dark theme. Okay, do not use these URLs. They are not compatible with Leaflet. Choose it from the URL that I have shared. You can choose any of them from there. It will work. Okay, so any questions so far in this, what we discussed? Or you have any doubts regarding how to practice JS or anything, you can let me know. I can like share resources or see how what we can do. Because I don't know how many people are interested in actually learning the web application part.
And you can share the JS tutorials and so we
The
can
PPTs obviously I'll share the PPT I'll share. I have put a resource for JS also. I've put a link to W3 School. When I
Okay.
started learning, I have also referred to W3 School only. So I'll recommend that for having a basic concept about JS, you can go through this tutorial and they have everything about basic HTML, CSS, and JS. You'll be able to get a grasp. So if somebody is interested, you can go through it and learn about it. Otherwise, the integration and everything, obviously, I'll cover in the sessions, but how to write functions, how to create variables, the concepts and
Mm.
everything, you need to learn it on your own. Okay. Okay. Any questions? Otherwise, we can. A marathon, we'll do it on Saturday because it's not possible on weekdays. And actually, I was little busy with, I have to transition from my previous job. So that's why I couldn't do it on weekend, last weekend. Okay. And keep your capstone also ready because like by the end of this session, we'll also see to we'll use. I'm figuring out like what server and what open source tech we should use so that you can also host your application and create a basic web application of whatever capstone that you have created. So keep all your things ready so that you can get it together. Okay. While we are ending this session. Okay then.
Uh, we just need the basic concept of JavaScript for entire of this.
Yeah, you just need a basics. See, if I'll say that you just need a basic, I'll be very wrong because let's suppose it depends upon how far you want to go. Let's suppose you want to add drop downs, you want to add tables, you want to highlight the features on the map. So obviously you have to go a little far into how you write those functions. So yes, but if you start learning now, it will be done. For your capstones, I'll be helping you with the codes and everything. I'll be providing you. But for learning, you have to do it like start learning by basics.
I will share the today's code. Right?
I have already shared. It will you'll get this by after like in an hour. Okay.
Okay, fine.
Mm.
Thank-
The screenshot is there in the PDF. You can copy paste the code from there. It is the same code.
Okay.
Okay. Okay then. Good night, everybody.
Ma'am, one
Yeah.
query.
Hmm. Yes.
Ma'am, actually, while yesterday I was facing an issue.
Yes, you can share your screen.
Ma'am, while downloading this
Mm.
for MacBook,
You can choose 11 for now. Okay, download the .pkg. Everybody else, if you want, you can leave the sessions. There's nothing extra now.
.msi is not available actually
So
for
.msi is
7.
not, it's not available for Mac, I guess.
For 17 and before.
Uh,
It is only available for 25.
no, but we are not downloading 25 because it is not compatible with GeoServer. Okay.
Mhm.
Just a minute, I'll search for the Mac.
Then I guess.
You can install this .pkg as well. Try this. We'll try with this. Have you installed?
This would work.
What version have you installed?
It's 11.
11. Okay. So, and which one? .msi or
No, ma'am, not MSI. It was.
pkg?
Yes, ma'am.
Okay, fine. No
Ma'am,
problem.
it's done. I guess it is there.
Hmm.
This one.
Okay. Now open the command prompt.
So,
And check the version of Java.
it's not showing.
Just a minute.
Writing
Write Java space dash and version.
hash version.
There should be a space after Java, no?
Okay, ma'am, just a second.
Space dash. This now version.
Still,
Wait, it's there. So 11. Okay, fine. So now your Java version is there. Now I have to see how to set the home and everything in Mac. Give me a minute. Now copy this in your C drive.
ma'am, C drive is not there.
Okay, like
It's
where you keep all your setups, program files, such kind of thing. How do you install that?
documents.
Okay. Hmm.